Okay, these are the outside of class examples for 1.5 and 1.6. Okay, so here we go. So as x approaches 5, from a little bit bigger than 5, and so, what's that, the right side? Yeah, the right side, from the right side. And so I noticed that if I substitute it in 5, that I do get, let's see, when I put it in 5, I get 6 over 0. And so because I have a number over 0, that tells me this is an asymptote. Which means that if it's one-sided, the answer is either infinity or negative infinity. And so it's either, as it approaches 5, it's an asymptote. It's either going like this, because we were saying, ooh, on the big side of 5, whoops, on the other side. It's either going up like this, or it's going like that. And that's what I've got to do, is I've got to figure out, because it's a little bit bigger than 5, I got to figure out which one of those that it is. And so I just kind of tell myself, if I'm a little bit bigger than 5, since I know it's going to be infinity, that's 0 in the denominator is making my infinity, then if I'm a little bit bigger than 5, then my numerator is positive. And if I'm a little bit bigger than 5, so like 5.1, a little bit bigger than 5, take away 5, my denominator is positive, but 0. And I'm going to say near 0. So what I have is a positive number divided by a positive number that's near 0. It's the near 0 that made it infinity in the denominator there. And then a positive divided by a positive is a positive. So this is positive infinity. If I plug in 5 in 27b here, I get if I plug in 5, I get 6 over 0. So it looks very much like this one here. And I say, oh, this is an asymptote. When you have a number over 0. But instead of me saying to myself, well, it's positive infinity because it's 6 over 0, just like this one was, no, you still have to reason it out. And so if I'm a little bit smaller than 5, that's like 4.9, something like that, and I add 1, my numerator is still, right, a little bit smaller. My numerator is still positive. If I'm a little bit smaller than 5. But if I'm a little bit smaller than 5, like 4.9, and I take away 5, now I'm just giving you an example of 4.9, but it could be 4.9999 or 4.9999999, right? But, so I'm not saying what the number is, I'm not plugging in a number, I'm just kind of thinking, if it's just a little bit smaller than 5, and I take away 5, then that result will be negative, right? Like 4.9 to minus 5 is negative. But near 0 still. So now what I have, the near 0 in the denominator is what makes it infinity. And now I have a positive divided by a negative is a negative. So this is negative infinity. Then I have the limit as x goes to 5, same function, and that's a two-sided limit. And so since that's a two-sided limit, when I go to plug in, I'm going to get the same thing, 6 over 0, it's going to tell me an asymptote. But on a two-sided limit, what you have to do is you have to verify that the right side and the left side are equal to one another. But when we go to find the limit, this is going to be the left-hand limit, the left-hand limit. The left-hand limit is 5 plus. No, that's the right-hand limit, 5 minus, a little bit smaller. We said that that was negative infinity versus the right-hand limit, which we said was positive infinity. They have to be the same, otherwise the limit doesn't exist. So we can't say infinity doesn't exist. Okay, but in order for us to say, we can say it does not exist, but it's approaching positive infinity. It does not exist, but it's approaching negative infinity. And what's happening here is it doesn't exist, and it's not approaching positive infinity or negative infinity. One side's going to positive infinity, the other side's going to negative infinity. So this limit does not exist. And so that's kind of our story there. Because we had kind of set it up with 27A and 27B, I think I would have written over here, you know, I just want to show you this is what I was thinking. But because I had just done that one and we can still see the answer for both of them, I might have said just the left-hand limit doesn't equal the right-hand limit. And so therefore we have does not exist. So we're going to try 31A here. So we're approaching -2, and so I can see that the numerator as I approach -2 is -3, but the denominator as I approach -2, this is 0, and that's 4, so 4 times 0 is 0. And so this tells me that I have, because I have 0 in the denominator and a number other than 0 in the numerator, an asymptote. So I have that same situation. I almost don't have enough room on these, but it's an asymptote. And so now all I have to do is figure out, since it's a one-sided asymptote, the answer is either infinity or negative infinity, so I want to figure out which one. So as I approach -2, but from a little bit bigger than -2, that numerator up there, as I'm close to -2, is equal to a negative value. The denominator, as I approach -2 from a little bit bigger than it, when I square something, I get a positive value. So when I square that, I get a positive value, because when you square it, right, everything's positive. And then as I approach -2 from a little bit bigger than -2, now things that are a little bit bigger than -2, think about your number line. Here's -2. That means they're on this side of -2 a little bit bigger, like -1.9, for example. And if I put in a -1.9 and I add 2 to it, it's nearly 0. -1.99999 is nearly 0. And all of that, because this negative is smaller than 2, is positive. So this is positive 0. And so since nearly 0, right? I'm going to say near 0. Positive, but near 0. So it's the near 0 part that makes it infinity. And we get a negative divided by a positive in the denominator is a negative, so negative infinity. And now they're asking us, approaching -2, but from the left-hand side. And so that was from the right-hand side, now from the left-hand side. So we're going to give a try to that. We still have here, if we were just to do this problem on its own, -3 over 0, which is an asymptote. So we still have that same idea. As we approach -2, the numerator gets close to -2, but is a little bit smaller than -2. The numerator is still a negative value. Squaring our -2, something a little bit smaller than -2, is still positive, because when you square anything. And then now I'm over here on this side of -2, a little bit smaller than -2. So that's things like -2.1. And so if I kind of think about that, -2.1 plus 2, that is negative, but near 0. So now I have a negative divided by a negative, right, is a positive. So this is positive infinity. And then because I've just done the left and the right, the left-hand limit doesn't equal the right-hand limit. We just did that in 31A and 31B. Therefore, this is from both sides does not exist. And so we did a lovely job on that one. Now we're going to do 33, but I'm going to have to shake the mouse because I didn't put my code on this morning that helps me. So I'm going to shake the mouse a little bit, otherwise it'll go off. Secant is 1 over cosine. And so, and the cosine of pi over 2 is 0. And so secant at pi over 2 is undefined because 1 over 0 is undefined. And so what I want to do in order so that I can kind of see what I have is I want to write this as cosine. So the limit as x goes to pi over 2, I'm a little bit bigger, and this is going to be x over cosine of x. And so as I get to pi over 2, this is getting to 0, so pi over 2 times 0, cosine of pi over 2. So this is 1 over 0. And so I know it's an asymptote because it's a number over 0. Sure had a lot of these examples. And so, but I think that it's probably good. And so now I want to figure out, is it positive infinity or is it negative infinity since it's a one-sided limit? And so your choices on how you go and you think about that. Obviously, the numerator is equal to 1, which is a positive value. If I'm a little bit bigger than pi over 2, and that's x right there, well, that's a positive value. But what about cosine as it approaches something just a little bit bigger than pi over 2? And so if you're thinking about that, I'm kind of thinking about my unit circle right here. And let's see, all students take calculus. And if I'm a little bit, pi over 2 is this angle right here. And so if I'm just a little bit more than that angle right there, just a little bit bigger than pi over 2, and then that would put me in the, just slightly into the second quadrant. And in the second quadrant, sine is positive, but cosine and tangent are negative. And so if I'm a little bit into the second quadrant, then cosine is negative. And so this would be negative, but nearly 0, because the cosine of pi over 2 is 0. And so it's negative, but near 0. That almost looks like a G, but near 0. And so that's going to give us negative infinity. And I'm going to shake the mouse so that it doesn't go off, because that would be awful. And then if I come here and do the same thing, this is the limit as x goes to pi over 2 from a little bit smaller than pi over 2, and this is 1 x cosine of x, so same thing that we had over here. And so now I'm going to go figuring out, I have an asymptote again, this is 1 over 0, so same story, and I'm going to be a little bit, right, a little bit smaller than pi over 2. So my angle here is a little bit less than pi over 2, which puts me in the first quadrant. And all of the values are positive. Sine is positive, cosine is positive, and tangent is positive in the first quadrant. So as I'm approaching a little bit smaller than pi over 2, that is a positive value, right? 3.14 divided by 2 is 1.57, whatever it is. It's positive value. And when I do the cosine of it, I'm in the first quadrant, and the first quadrant cosine is positive, so it's positive, but near 0. And so this is positive infinity. And again, just the same as we had on that last example, the left-hand limit and the right-hand limit are not equal to one another. So if they asked us for the limit as x approaches pi over 2, because the left and the right-hand limit are not the same, left-hand limit does not equal the right-hand limit, we can say that this limit does not exist. And of course, they don't always ask us all three. These problems in your book, they actually ask you just one of them, and so you would be figuring out just one of them, but I just wanted you to look at all of them. And so if they only asked me this one, I wouldn't be able to say the left hand doesn't equal the right hand limit without showing that, and I just showed that. So just so that you know, if they'd only asked me this one, then I would be doing this problem and that problem right in that space. Okay, so 35, and I hope it's the last one, and I think I have all of the answers there, and hopefully correctly as well. So we're gonna give a try here. to this one. Okay, so as I near 1, the numerator is 3, and the denominator, that's 1 squared is 1, minus 2 plus 1 is 0. And so again, we have an asymptote. If you notice that things factor and you want to factor them, that can be helpful to go through, and if you notice things are factorable, to factor it when you're making your decision. So if you wanted to go and factor it, this is the limit as x goes to 1 from the positive side of x times x plus 2. And the denominator factors as x minus 1 times x minus 1. And so if you wanted to, you could go ahead and factor it. If you want to write that as x minus 1 squared, you definitely can. Can you figure it out without factoring it? And the answer is probably, but I think it is a little bit easier if you notice that it factors to go ahead and factor it. Now, as I approach 1, the numerator is a positive value. So as I get close to 1, the numerator is a positive value. This is positive, and when you add 1 onto 2, it's positive. So this is a positive times a positive up there in the numerator. And the denominator is squared. So as I approach 1, it doesn't matter if it's a negative squared or a positive squared, it's positive, but it's near 0. And so when you divide that out, you have positive infinity. I have room. The same reasoning would go on here. You would have 3 over 0. As you approach 1 from a little bit smaller than, your numerator is going to be, I would factor it the same way as I had over here. So the limit as x goes to -1 from a little bit smaller than, x times x plus 2 over x minus 1 squared. As I get close to 1, like 0.9, that's positive. 0.9, if I add it onto that, is positive. So this is a positive times a positive in the numerator. In the denominator, I'm squaring, so whatever it is, positive or negative, it doesn't matter. When I square it, I get positive. Yes, it is near 0, because if it's close to 1, that value that I'm squaring is very close to 0, so near 0. And this is also equal to positive infinity. And then when they ask us about c, because the left-hand limit is equal to the right-hand limit, they're the same with one another, we can say that the answer here, it's approaching positive infinity from both sides. And so, anyway, so that's kind of our story on those. And there is hopefully enough time to do this one. So this one is more outside of class, examples 1.5 and 1.6. It says, it's problem 2, the graphs of f and g are given, use them to evaluate each limit if it exists. If it does not exist, explain why. And so as I approach 2, the limit, as x approaches 2, f of x, the limit exists here. And as I approach 2, the limit over here is going to exist. So because both limits exist, I can write this as the limit as x goes to 2 of f at x plus the limit as x goes to 2 at g at x. And so this limit right here, when you go and find it on your graph, as you get closer and closer to 2 is -1. So this limit right here was -1. Now I'm going to go find this one. As I get closer and closer here, I'm getting closer and closer to 2. So this one was getting closer and closer to 2, 1, 2, right? As I get closer and closer to 2. And so this answer is 1. Part B is asking at 0, And so making sure f exists at 0, the limit as x approaches 0 of f of x exists. But this one does not exist. So I won't be able to, oh, I'm gonna have to do this video. This is gonna get too long. And so I'll have Kevin erase this last part. Okay, we're gonna have our class